Hey guys, welcome to lesson 6.2, where we are going to talk about the sine and cosine ratios in addition to tangent, which we talked about yesterday, and also this acronym called SOHCAHTOA. This is something that is very useful in remembering what each ratio means and how we use them and like what qualifies us to use them. Okay, so yesterday we talked about tangent and we talked about how it was just the slope ratio of a line, right? And when we talk about it in terms of a right triangle, it really is just a ratio between two of the sides of that triangle. And so sine and cosine are also just ratios in a right triangle as well. They're just two new combinations of sides. So here I have a really helpful graphic that shows what each one represents and how to create these ratios. So here we have tangent, and it is the TOA portion of SOHCAHTOA, and the reason for that is because the tangent ratio is the opposite side over the adjacent side. Now, yesterday we talked about the tangent ratio in terms of slope and, rise over run or height over base, and now we have new words, and those are going to be opposite over adjacent. And the opposite side is always going to be the side directly across from the angle in question. So if you draw this arrow out from the angle straight out, it's going to land on the side that you would then call opposite. All right, and adjacent is the side directly next to the angle. It's touching the angle. And, adjacent actually means like right next to. And then this long side, as you guys know, the longest is always the hypotenuse. All right. So tangent only deals with the opposite and the adjacent. Cosine deals with the adjacent and the hypotenuse. So adjacent is right next to it, hypotenuse is the longest, and adjacent over hypotenuse is how you would set up that ratio. And then sine is opposite over hypotenuse. So that's going to be this guy right over here over our longest side. Okay, now this is where SOHCAHTOA comes from. Because SOH means it's sine, S is for sine, and OH means O goes over H for the sine ratio. This right up here that I'm writing is another way to write SOHCAHTOA that helps people remember a little bit more specifically how this works. So C stands for cosine, and cosine ratio is adjacent over hypotenuse, hence the A over H. And T stands for tangent, and tangent is opposite over adjacent, which is why we have O over A. Okay. Down here, there is a new set of pictures just to show you that these ratios and the location of each of these side labels changes based on which angle you are talking about. So like here in this top triangles, the angle in question was the bottom left angle, right? And we learned yesterday that when we took tangent, we always took a tangent of an angle. But the triangles aren't always going to look the same. So if you have a triangle like this and you're looking at like the top angle, now opposite is the bottom side because that's now the side that's the farthest from the angle, okay? Remember, anytime you draw an arrow straight out of the angle that we're working on, that's going to land on the side that you would then call opposite. All right, hypotenuse doesn't change. It's really just opposite and adjacent that get flip-flopped when you use a different angle in the triangle. And this is going to make a lot more sense when we do some examples. But this is all called right triangle trigonometry. Okay, and it's called this because it's a part of trigonometry that's specifically used to calculate sides and angles of right triangles only. There is, there are wings of trigonometry that are used for regular, like all kinds of triangles, but we are not going to be learning that in this class. And we use these ratios to find missing sides of right triangles. All right, so here I have some steps as to how you use the ratios to find missing sides of triangles, along with an example that we'll do as we go over these steps. So the first step is to label the sides. So if I give you a problem, this is what it would look like. It would just be a triangle with two sides labeled as well as an angle. And the first thing you want to do is label your sides with O, A, and H. That stands for opposite, adjacent, and hypotenuse. Only label the sides that actually have something on there. Like this side is empty, so we would just ignore it. That'll just help you like make sure you don't choose the wrong trig ratio. But in this case, we know that 17 is the longest side, so we're going to label that with h. It must be the hypotenuse. X is the side where if we draw an arrow straight out of the angle, it lands there, so that means it's O. It's also the farthest side from the angle. So that's all you have to do for step 1. Obviously, that means this side has to be A, but again, I'm just going to ignore labeling that side so that we don't get confused on what information we have and don't have. Okay, step 2 is to choose the correct trig ratio based on the letters that we labeled. Okay, so if we labeled O and H, this is why I told you to ignore A, because we only have things on these two sides. You look up here and you say, okay, well, sine deals with OH, cosine deals with AH, tangent deals with OA. So it must be sine that we're using because we only have O and H to work with. All right, so since we're using OH, we have to focus on the SO part of SOHCAHTOA, which means we are using sine. Okay, if we had AH, we would have used cosine. You just choose based on the information that you have. Whichever sides are labeled, that's what you're allowed to use. All right. Step 3 is to set up a proportion using the trig ratio and then the side ratio. So you're always going to set up the first part of your proportion using the trig ratio that you chose. So because I used sine, or I chose sine, I'm going to start by saying sine of our angle. Our angle is 59, so I'll write 59. And the SIN is the abbreviation, the short form for sine that we're going to be using. You will always put it over 1. And then on the other side, we use the O over H thing. So our O over H would be x over 17. Okay, so the reason we put the sine of 59 over 1 is so that we can have a proportion and we can cross multiply. So it just makes it easier for us to solve. Okay, step 4, the final step is to actually go ahead and solve this. So I'm going to just rewrite my proportion here to make it easier to work with. Okay. So now I can cross multiply just like we are used to. So here's one diagonal, and here is the other diagonal. Now it looks a little weird because of these like letters, but it works exactly the same way. So one diagonal is going to give me 17 times the sine of 59, and the other diagonal is going to give me 1 times x, which 1 times x is just x. So lucky for us, this time I don't actually have to do any extra work to solve for x because it's already by itself on this side of the equal sign. Sometimes that will happen, and in that situation you just have to pop this into your calculator to get your answer. So I'm going to go ahead and pull up my calculator here and type in exactly what I see. So 17 times the sine of 59. Okay, just to make sure you all can see this. All right, this is what I typed. I'll press enter, and I got an answer of 14.57. So I'm going to go ahead and say that my answer is 14.57. All right. That means that that missing length of my triangle is 14.57 units long. All right, so let's move on to some more practice problems. Okay, there's 3 here for you. And I'm just going to go ahead and write our SOHCAHTOA thing in that other way because that's pretty popular. All right. So for this first problem, this first thing you want to do is label your sides with O, A, or H. So this X is the longest side, so that's H. The 3 is right next to the angle that we're looking at, and it's not very far away, so this is going to be A for adjacent. All right, because we're using A and H, now we're ignoring this side because it's empty, there's nothing there, we can't use it. So because we're using A and H, we look over here and say, okay, which one of these can I use? Because the C is the one with the A and H, we have to use cosine because it's C for cosine, right? T for tan, tangent, and then S for sine. So I'm going to stick to cosine, and that means I can go ahead and set up my proportion. I'm just going to make a note here that I'm using cosine. So I'll say, all right, cosine of my angle, in this case it's 17, over 1. Remember, it's always going to be over 1. And then equals, it's a over h, so don't get them flipped. A over h is 3 over x. So now that we've set up our proportion, we're ready for step 4, which is to cross multiply and solve for x. So here's one diagonal. Here's the second diagonal. Okay, so let's set up our equation. We have x times cosine of 17 for one diagonal. And then the other diagonal is just 3 times 1. That just equals 3. So we'll just write 3. And now you have to treat this like any other number. It would be the same thing as if it was like x times 10 equals 3. You know, what we would do to solve this, it would be to divide both sides by 10, right? A lot of you guys will look at this and be like, oh, well, let's divide by 10 on both sides and solve for x. Just like that, I'm going to erase that, we have to do the same thing here, which is to divide both sides by whatever is stopping x from being alone. In this case, it's cosine of 17. And cosine of 17 just represents a number. It just hasn't been calculated yet, so it's okay to divide by it and stuff. It's just a number. All right, so my answer is going to be whatever I get for when I do 3 divided by cosine 17. So let's pull our calculator back up and type that in. So we'll write 3 divided by cosine of 17, just as we see it. Press enter, and we get 3.137, so I'll say that's 3.14 when I round it. Okay, and that is it for that problem. So just remember, if you're solving for x, that's the hypotenuse, you're going to have to divide by your trig function. That's just how it ends up working out. All right, number 2. Step 1, label your sides. So this is the longest, so we'll call that h. This one is the one where when you draw an arrow out, that's where it lands, so it's going to be O. Because we're working with O and H, we go back up here and we're like, okay, well, S is the one that has a O and H, so we must be using sine. So we can set up our proportion using the sine ratio. So we'll say sine of 34 degrees over 1 equals O over H, right? That's what it told us to do, was O over H. So in this case, we'll do 13 over X. We are now ready to cross multiply and solve for X. Alright, so the green diagonal gives us X times the sine of 34. And the red diagonal is 13 times 1, that's just 13, so we'll just write 13. Now we're ready to solve for x. Again, just like the last problem, in order to get x alone, we need to divide both sides by sine of 34, so that these cancel. So my answer is going to be whatever I get when I type 13 divided by sine of 34. Okay, I got 23.247, so I'll say 23.25. Alright, we have one last problem here, and this is a 62-degree angle, and let's go ahead and label our sides first. So this side, that's where I land when I do my arrow, so that's going to be O, that's the opposite. And then this side is right next to the angle, but it's not the longest. So this has to be A, right? Because this one is H because it's the longest, so we just ignore it because it's empty. So OA, we scroll back up to our SOHCAHTOA and we're like, T is the one that's written with OA, so I have to use tan. Alright, I'm going to go ahead and set up my proportion. I'm going to pause the recording as I do that because I'm running out of recording time here. So here's my proportion, and then I'm going to solve it and we will come back. Alright, so I set up my equation with the cross multiplication and I divided both sides by tangent of 62. So here I've typed that in the calculator and I get 2.66.